All right. So let's go over some PowerPoints, and then if I need explanation, I will use a whiteboard to do that. Oh, by the way, next week is a Labor Day break, but it will not affect this class. However, we will turn Wednesday's class to online only. Okay, online only for next week. So let's do slideshow, starting from beginning. All right, so this is a simple review. Database is a set of records and has to be well organized using a logical data model. And the record is just a bunch of data observed on one object, one record, one object, okay? And the records are basically unit of database. The relational model basically stack all records into tables. The table is also called relations or file. And each table have like columns, attributes, fields, or rows or tuples. So basically we have 3 identical interchangeable names in different contexts. Okay? And the network model, hierarchical model using pointers, but then for relational model, we're using key by sharing key fields, primary key or ID fields. Okay? And because of that, the ID of each record is called a primary key. The duplicated primary key is called a foreign key. A very simple name, simple concept. All right. And then how do we duplicate the primary key? That depends on the cardinalities. We are going to learn that, how we do that today. Okay. And then in terms of a database development process, we basically go through 3 stages. First stage is to create a business data model. Business data model is also called a conceptual data model. Okay, so the purpose of that is to capture the user data requirements. Business data model is to capture user requirements. And then we convert business data model into logical data model. A logical data model, you can think of that as like a blueprint, a specification for database. Okay, so we need to convert that logical data, conceptual data model into logical data model, the second step. The last step will require you to use a programming language like a COBOL or SQL to actually create database. Okay, so in this class we'll be using SQL. All right, and then in terms of business data modeling, basically it boils down to 3 simple steps, 3 simple tasks, not a simple task actually. First step is identify objects. What are the business stakeholders objects that you want to keep data? Then second step is to identify what data you want to identify. Okay, so object can be tangible, can be intangible, like concepts, like meetings or counts. Even though they are not tangible, but they still can be objects. Okay, attributes just like properties of those objects. So which basically just tell what kind of data you want to capture about, say, a particular object, like an account or like a student, like a meeting. Okay, so make sure that the data to be identified will be relevant ones and will be single valued, not a composite or not multi-valued. And there must be native ones, not attributes from another object. Okay, and then attribute will be marked with identifying ones, like IDs, and will be marked whether it's required. So you have to have the value for you to put the data into database or to be recorded, and whether it's optional or not. Okay, and then we identify relationships. Regarding relationships, make sure you understand that each relationship is reflecting the nature of the real-world relationship. So basically, you have to have a verb describing the relationship. If you cannot think of a verb to describe the relationship, then you probably do not have a relationship. Okay, question? Multi-valued is just something like an attribute may have multiple values for one object. So for example, let's say an employee may have degrees, right? So one person may have 1 degree, some people may have no degrees, some people may have multiple degrees, like a PhD, master's, bachelor's. Okay, so in that case, the attribute degrees will be potentially multi-valued. Okay, so similarly for students, some students may have 1 major, some students may have multiple majors. Okay, so majors might be multi-valued attributes too. Okay, so all those attributes cannot be allowed as attributes inside an object, inside the entity. So how do we handle that? We will handle that using a concept called weak entities. We are going to talk about that today. All right. And also that relationship should reflect business rules. So business rules basically say, given the record, you want to navigate to related records. So if you have such a need as a business rule required, then you probably have a relationship. Okay. And if action verb itself need the data to be described. For example, when customer purchase orders, the purchase action itself needs to be recorded, like the purchase date, purchase time, purchase location, all that to be recorded. Then the purchase action must be also recorded as objects, must be also identified as objects. And that in that case, it will be identified objects to cut in the middle. We'll have a few more examples on that. Okay, so here we have examples. So employee manager accounts. Employees manage accounts. So in that case, employee manage accounts. You probably do not want to connect employees with accounts directly. Instead, if you think that the management action itself is important, okay, so some employees may be open accounts, some employees close accounts, some employees may be doing some kind of transactions with accounts. So in that case, you probably want to convert that action, the employee actions into something like a transaction, and then connect employee with transaction and transaction with account. Make sense? Okay. The second example I just explained, customer purchase products. Purchase, more like a transaction or maybe like order. So you should have that to indirectly in the middle, cut in the middle to indirectly connecting customer with product. And what about student resolve books? Student resolve books. So here resolve is like action, reservation. Do you need to have data on the reservation itself? Of course, right? So when you have a reservation, when you make a reservation, the library want to find out not just what is resolved, but also what time you made the reservation, and then if there's any like a priority set for the reservation, all that. So you probably need to keep data on the reservation itself. So now you're going to put a reservation as a verb, as a like object to cut in the middle between student and the book. And now the book, library book actually have two different concepts. Did you realize that? One is more like a catalog entry book, which has like an ISBN number, title, description, all that, right? And the second one is actually a concrete book, the book copies. Okay, and they are different things. Can you realize that? They are different things. Okay, so book copies have like condition, have number of pages, and you have like a purchase price, all that. All right, so when you resolve books, you actually resolve the book title only. You'll not resolve or concrete copy, right? So make a reservation, I want to have that title. And then, whenever the copy is available, then you'll be sent, you'll be given that particular copy. So when you resolve a book, you resolve book copy. On the other hand, when you check out books, you check out book copies only, right? So again, when you do checkout, when students do checkout, do you need to have action on checkout itself? Yes, of course. You need the checkout date, you need a due date, all that to be set for the checkout, right? And so you're going to have a checkout action, as object to cut in the middle between student and a book copy in that case. Okay, and another concept. So what is the relationship between book and a book copy, by the way? Book and a book copy. So of course they have relationship, right? So book copy is just like one of a copy under the book title, right? So in that case, you could, let's just say, let me try to use a whiteboard to explain that. This is actually a concept related to something called weak entity. Okay, so let me clear everything here first. So it's tempting to do, say, if I try to create a book class, book title, book class, book object. Okay, So you're going to have I, S, B, N, that is ID, identifying field, and then you have title, right? And then you have abstract, and then you can publish. Okay, publisher could be just like a foreign attribute. If you have already have publisher, then you can get rid of that. So let's say I want to get rid of that. Okay. So then you have publisher as separate box, separate entity, publisher. And then you can connect that with one-to-many relationship, right? Publisher has many books, publish many books, right? Now, what about copies? Copies. So each book may have multiple copies, right? So now this is actually a multi-valued attribute. Multi-valued attribute. So this is not allowed. Okay. So the way to handle that is we are going to create a separate entity for that. So we may call that as a book copy. Okay. And each book copy is, of course, is going to have a copy number. And that copy number is just simply like a copy 1, copy 2, copy 3. Make sense? So this copy number is just simply 1, 2, 3, just those numbers, okay? And then you may also have other things like, say, condition, whether the book is damaged or not. Okay, it's new or damaged. You can also have some other things like, say, purchase price. Purchase price. So that is related to, say, in case the book copy is lost or damaged, then whoever lost it or damaged it should pay for that price, right? Purchase price. And then what is the relationship between these two, between this book copy and the type, is going to be so-called one-to-many, first of all. That makes sense, right? Each book title is going to have multiple copies. Secondly, this is not a regular object. It's a weak object. So we use this little bar to indicate that it's weak. So what does that mean? That means that this book copy cannot be uniquely identified by itself. Does it make sense? So for example, I have one title, database management, and has copy 1, copy 2, copy 3. And now another book called systems analysis, which also have book 1, copy 1, copy 2, copy 3. So those 1, 2, 3 will not uniquely identify each copy, right? Only if the copy number combined with the book title or ISBN, then this copy will be uniquely identified. And this is what it means. So that means this book copy has to use this ISBN number, has to use this relationship with book to be uniquely identified. So therefore, this is called weak objects or weak entities. Depends on the title to exist. Yeah. So yeah, for example, just imagine in the actual database, if you delete the title, then you're not going to have records on the copies itself, right? So the copies will be deleted too. So the copies depend on the title to exist. Make sense? Okay. And there's some other example. Let me show you some other examples. So here, suppose I have employee. Employee have employee ID, employee job, and employee last name, first name. What about employee dependents? Multi-valued again, dependents. So it's not allowed, right? So we take that off and make it a separate box called dependent. Okay, and then dependent have dependent number, dependent 1, dependent 2, dependent 3, and may have first name, may have a relation with the employee, right? Spouse, well, daughter, son. And then you connect that with one-to-many relationship again, and then this is weak entity because dependent cannot exist. It depends on it depends on employee to exist. So dependent will depends on the employee ID and also dependent number to be uniquely identified. Okay, just merely by using dependent number 1, 2, 3, you cannot uniquely identify all the dependents because you have dependent 1, dependent 2, dependent 3. I also have dependent 1, dependent 2, dependent 3. Make sense? So you have to use my social security number or whatever number along with that dependent number to be uniquely identify my dependents. Okay, so this little bar just indicating that. So it's always one to many, that's correct. Yeah, it's always one to many. Okay, so now let's go back to the PowerPoint. Go through a couple more relationships. Okay. So we did a book copy, and that will be handled as weak entity of book title. And then doctors prescribe test. And this is actually something also, we have two concepts here, test. There's catalog test. So for example, in hospital, in clinics, you have like X-ray test, blood pressure test, blood test, or different kind of test, right? So they have catalog. So each one, we have like a description, we have like a list of procedures and also like a price or whatever. But then when doctors prescribe tests, the test will be done actually on you. So that will be actual performed test or scheduled test. So we have two different tests, actual test and the test catalog. So that is also a relationship between weak, strong entity and weak entity. Catalog test will be strong, and actual performed test will be that actual test will be a weak entity here. So in this case, actual test will be cut in the middle between doctors and the catalog test. Okay, so doctors performing test on prescribing test on actual test, and the test is weak entity of catalog test. Okay, what about student, professor teaching class, teaching students? So again, the teaching action itself, teaching more like a session, something, that's class, right? So you have to have a class in the middle to cut between professor and the student. Okay, but what about professor or the vice student? Or the vice student. So in that case, it's basically just like more like assignment. This professor is assigned to advise this student, or so on and so forth. So you really do not need to keep track of data on the action itself. So then you can directly connect professor with student. Okay. So it's unlike a teaching action. So basically meetings, every meeting we have to have data, right? So that we need to have something in the middle, which is a class. Okay. Now for the last two, I want you to think about, so customer wish list products, the customer rate product. So should you connect them directly or not directly? So wish list, you understand the wish list, right? So basically, say if you go to Amazon, say I want this product, in my wish list, right? So every customer may have one wish list, right? Okay, and also customer can go to online to rate products. So I like this product and this blah blah have a bunch of ratings, right? And then how do you keep data on those? So think about those last two examples. All right, and then regarding cutting, question. Yeah. So professor or the vice students, we're assuming that you do not need to have data on all the vice and sessions, different actions, data on the action itself. So all the students, professor or the vice student are assuming that we just want to have data on, who is or the vice on whom, that kind of assignment, right? So in that case, you can directly connect professors with student. Make sense? Yeah. So as long as you can know, and if a business just say if I know a professor, I want to know who his or the vice is, or if I know a student, I want to find out who is his or the vice, right? So in that case, you really do not need to have like a data on the action itself, right? Make sense? Yeah. So assuming that in that case we'll connect professor with student directly. Unlike a class in that we need to have data on the actions, right? Meetings, right? Classes, right? So we will have something more to be in the middle between professors and the student. Okay. Regarding quantifications, quantification of relationships, just remember the relationship is more like it's not just one link between one object and other object. It's actually many links. So you want to say how do you characterize the links? Okay. So for example, if I have a patient may have multiple appointment, and each appointment is for only one patient. So basically, we're just trying to characterize that. Quantifying how many objects at the other end, it may be related to one object to the current object. So a patient may have multiple appointments. So on the appointment side should be many, okay? And then on the other hand, each appointment is for only one patient. So then patient side should be one. So then you come up with one-to-many relationship, okay? Optionality, on the other hand, is quantifying whether an object must relate to at least one other object. Okay, so a patient may or may not have appointment, right? So in that case, a patient is optional in this case. On the other hand, appointment, if you have appointment must be for a patient. So in other words, each appointment must be related to at least one patient. So you're going to say patient is optional, but appointment is required. Okay, mandatory. All right, and then let me skip that. Case 2 example. This is the example we did in class, and the banking system. All right, and then this is second example. Did we do that in the class? So here we have, so let's just look at this example here. Professor wants to keep data on his books, publishers, and authors. So what are the business objects? Books, publisher, and authors, okay? And now whenever he has comments, he can communicate with authors using emails, using US mail. So US mail is more like a composite thing. US mail address, basically you have to split into street address, city, state, zip code, okay? Because no field can be composite, okay? Must be single value. Phone and email, so those will be attributed for authors. I also like to have data on the publishers because he may need to go to a company's website and call the company. So company's address, company's attribute must have like a web address and also phone number. Okay, so in terms of the relationship, we have book, publisher, and author. What are the relationships in the real world? Authors write books, right? Publisher publish books, right? Now, what about the relationship between publisher and author? Can you think of any verb to describe in the relationship? Unless you know that there's a verb, otherwise, there's no relationship. So only relationship I can think of might be like this: or publisher hire authors, but publishers do not hire authors. Do you know that? Publishers do not hire. Publishers just, basically when you have a book, authors just contact publishers, say I have a book and this is my draft, and then you evaluate, say whether it's good or bad, and then then you accept for publication. So basically, there's no formal like hiring or assignment relationship between publisher and author. So therefore, there's no relationship. Okay. So if you it's tempting to connect authors with publishers, but then you think about that, there's no relationship. Okay, because you cannot think of any verb describing that. Question. Agent, if you introduce another thing, agent and a publisher. So what do you mean by agent? Author's agent. Suppose your authors have agent, and agents, these agents may work for certain publishers. So then, then you will have a relationship with agents. So agents work for publishers. So assuming that the agents have designated the publishers to work with. Okay. But for the professor case, he probably is not interested in that, right? Yeah. All three, yeah, the all three. Basically, there's a publisher publish books, authors write books. So they're all three related. Yeah, yeah. What about the professor? What about professor? Do you need a professor object in the case? So think about that database is designed for the professor, right? Does the professor really need to have a table to manage his own data? Not necessarily. So therefore, it's probably not necessary. Okay. Any questions online from people online? Okay. So I'm going to skip that. And then the student clubs, we already did that, right? In the class? Student club manages basically manage data on the members and the committees and the events. Okay, we did that. Okay. And today now we are going to do 2 more questions, and then we'll take a break, and then we'll do conversion, the last. Okay. So first example is auto system. So we can just think of like a online system that take all customer orders, and let's say what objects we need to do, attributes. Okay. So let's. I'm going to open up data modeler. Okay. So we're going to create the entity relationship diagram. So go to logical data model first. And then each logical data, each ERD is called subview. So we create a subview with a new subview. And now we are ready to put objects. So let's think of objects we need. So apparently we need, in the auto system, we need data on products, data on customers, right? Make sense? Okay, so let's have those 2 first. Okay. Select new and new entity. Okay, so customer. Attributes include customer ID. Let's just use characters. How many characters? Maybe 9 characters. Okay. And the customer ID is describing, is an identifying field. So UID, apply. Now, if you're behind, you want me to slow down, just let me know, okay? Otherwise, assuming that everyone is on track. Next one.
Can you please slow down?
Slow down, okay?
Yeah.
Okay. So next one is last name. All right, logical, char. And let's do 45 characters. And this one, let's assume that we need to have like a last name at least. So mandatory. Apply. Okay, so then first name. Logical, char, do 45 chars. And also required. And next one, the address, straight address. Logical, char, let's do 45 characters. And then you do have to have an address, right, for shading. Okay, next one, city, char, let's do 25 characters. So most of them are just characters. So mandatory. And then state. Let's just do char, the 2 characters. Required. Now zip code. Zip code. So zip code, Well, if we just use 5 numbers, then just numbers. But I will use char, and then 10 characters, because we may have like optional 4 letters. So that's also required. Okay. And finally, we should have email, right? For online order. And the email, let's just say I will have maybe how many? 50 characters at the most. Okay, let's just say that's required. And finally, we may have a password. Password, let's just say that is char, and typically 32 max, but it's not required. So some customers may choose not having a password. So optional. There we go. So we have one object finished. Now let's do product. Yeah. Not required. I chose not required. So assuming that some customers just want to check out as a guest, they never want to log into the website, right? And then product, TROD, attributes. So unique identifier for that is stock keeping unit. So that typically is some kind of characters. How many characters? Does anybody know? Or SKUs? 14? I don't know. I'm just guessing. So that would be UID. And then you're going to have description. So description is more like a title or some kind of words to describe in what the product is it. So we use char, and this char. Okay, so let's just say I will have like 50 characters at most. And let's make it required, mandatory. Okay. And now let's do, say, color. Color, that's also char. And how many? Maybe 12 letters. And let's just say that's optional. And then finally, let's say our price. Price is numeric. Okay, so now let's say the maximum, let's say samples, the product, the store you have, the maximum price is a couple $1,000. I will use 6,2. So that means decimal places are 2, and then whole digit is 4. Okay, so in total 6. So for that kind of precision, you can have up to $9,999.99 as a maximum price. Okay, that's apply. That's correct. You just I told you that this one has at least lot of data types. They are trying to accommodate in many different kind of databases. Some of them, for example, Microsoft Access will take money as a unit, like a data type, but Oracle will not, and some other databases will not. Okay, so for Oracle, the basic types are like charts, like numbers and days. Okay, so let's just stick with those basic ones. All right. Okay, so that is price. Okay, so now we have these two set. So now we say customer buys products and purchase products, and then we need data on the action itself. So we are going to create object for the action. So that will be typically called order or transaction, right? So let's say ORD, short name. Okay, attributes include order ID. And just imagine, just say we use how many? 9 digits, 9 letters for customer ID. So then the orders, of course, should be more than customers, right? So we should take maybe have a size bigger than number of customers. So we may use like a 12, okay? 12 as a order ID, 12 characters, primary UID, apply. And now order date, all date is date. So just simply choose date. Oracle date is actually very strange thing. It actually including both date and the time. So we'll use date for date, both date and time. And let's say order date is mandatory. Okay, apply. Now let's do promise date, T date. Promise date is also date. Okay, but then that may be optional. Not all orders may have a promise date. Make it optional. Okay. And then next, let's just say I want to have order amount, total amount, okay, in money, total amount. So that would be numeric, okay. And let's say the total amount, I will use 7,2. That means you can have up to tens of thousands of dollars. So you can have up to $99,999.99 as a maximum order amount. Okay. So I will make that as data type for order amount. Okay. I also made it optional today. Yeah, that's optional. Well, you can make it required. That's fine. For any money, it does not matter. By default, it will be 0. Okay. All right. So we have 3 things. Now we can make connections. So let me just make sure this is large enough for you to see all the attributes. And then this will be the middle, right? And then let's connect. So the relationship should be customer. This is just right in the middle because customer order products, right? So we should connect customers with orders. And that relationship is what? One to many, right? One customer make many orders. One order is made by only one customer. So we can choose one to many, one of that to simplify, okay? So one order, customer takes orders. So that is takes. So customer takes how many orders? Many, right? And one order is taken by how many customer? 1. Okay. And that is set. Now let's look at optionality. Is a customer required to have order? Not necessarily. Maybe just create an account, but the customer may have never made order yet. So that's optional. You see that? Okay. What about order? You can have order, so it's required. So must have a customer, right? Okay. So there we go. So we have that set. Okay. Now let's say order and the products, that relationship. So that should be many to many. Let's use that. Why is it many to many? Okay, let's say where the customer contains, order contains products. So one order may, of course, contains many products. That makes sense. Okay. What about a product? Can the product be contained in multiple orders? Now, this is something we should understand. Since we identify a product as one that has unique SKU. So with one unique stock keeping unit, we're not talking about individual products, physical products. We basically consider all the product which has same SKU as one product. Okay. So for example, all these computers in this room will be considered just one product. Okay. So this is a difference. So if you're talking about database design for some kind of an antique store, each product is unique, right? So in that case, one product will not be in multiple different orders. Make sense? So now here we're talking about the product is just like a group of products that have the same SKU. Okay. All right. So SKU, of course, the product may be ordered by multiple orders. So, for example, this computer university can order these computers, and then maybe another university, Kent State, also order these computers. So these computers, this one product may appear in different products, the different orders. Okay. Now the question is a product required to be ordered? Not necessarily, because maybe there's a product nobody want to buy. Nobody had bought. Okay, so this is optional actually. Make sense, everyone? Okay, so now let's Apply. Say it again. Order. Oh, yeah, should be, hold on. This should be not optional. This is required. Very well. Yeah, thank you. So order definitely will have a product, right? Otherwise, there's no order. Okay. Yeah. So that's right. So this should be optional. This should be required, and this one is optional. Okay. And then press OK. People online, can you hear? Can you see my mouse moving?
Yes.
Okay.
Yeah,
good.
I could see it.
Okay, good. All right, so now we have that. There's a basic three things, customer purchase orders. Now let's handle payments. Payments, of course, is different objects. So it has like a payment ID, payment date, payment amount, this type of data to be recorded. So we'll create another object called payment. Okay, let's just say the short name is pay. Attributes, pay ID. I'll use char. I will use 12 characters also. And that's a primary UID. Okay, and then P date, payment date. Okay, and then this is payment date is date. Okay, so let's say payment date is also mandatory. Then payment amount. So I will use numeric. Okay, and do the same thing as like orders 7,2. Okay, and that's just maybe required also. All right, so we have that object set. Now the question, which objects, how this payment object will be connected to others? So which object should be connecting to payments?
Customer.
Customer and the payment. So
customer makes payment.
That is correct. Customer makes payment. Yeah. So we need that. And a customer. So let's set up a relationship. Anyone. Okay. So customer payment makes payment. Okay. Customer can make how many payments? Many payments, right? Over time, right? So that's many. And each payment is made by how many customers? Just one. That is correct. Just one. All right. Now, does every customer have to have a payment?
No.
No, that's optional. If you have a payment, does payment must have a customer? Yes, right? So otherwise, how do you identify the source of the payment, right? Yeah. So yes, this is required. Okay, so this is correct. What about order and the payment? Order is paid by payment, right? Payment pays for order, right? Payment pays for order. Okay, so that should be connected too. So now let's create a relationship between payment and orders. So we just say pays for. So payment pays for the order. One payment pays for how many orders? Just one, right? And then each order is paid by how many payments?
One.
Just one. So it's a one-to-one relationship here. Okay? And if you have a payment, do you have to have an order? So is the payment optional? If you have a payment, of course, it has to be paid for order, right? So you have to have order. So this is not optional. On the other hand, order may or may not have a payment because some orders may be free, right? You don't have to pay. Okay, so I will make that as optional. Does it make sense? Good. So now we have that relationship set. Okay, and before we finish this, before I put this aside, let's do one more thing. I need you to think. How do we handle that? That is, if I have order same product multiple times, multiple items, how do I do that? For example, I order this, 24 of these computers in one order. Where do I put that 24? Also in the same order, if I say I ordered 15 keyboards, where do I put data on the 15, the quantity? So that the quantity depends on the order and also depends on the product, right? Make sense? So maybe in one order, I order these 24 computers, but in another order, I order the 15, I order the 36 computers, okay? So it depends on the order and also depends on the product you order. So maybe in one order, I ordered 5 apples and 10 bananas, right? So now we have a situation that we need a data describing something that depends on both. So really describing the relationship. Data describing the relationship. Make sense? So the way to handle that is I'm going to get rid of this relationship and represent the relationship. You remember the relationship is just a bunch of links, right? Product and order link, right? Many of those links. So let's just imagine I put those links, make those links as object, and then create another box for that. So create a box. Let's just say that is order line. Order line. Okay, so you can say in the order you have multiple lines, right? Each line is representing one item, right? And each item has multiple quantities, right? And also subtotal, right? This kind of things. So order line, let's say OL, let's show the name. Now attributes we have is just simple, just say quantity. Quantity. So let's just use numeric for that. Okay, so I will use 3,1, just in case we have decimal places, maybe like a pounds, right? How many pounds? 0.5 pounds, whatever, okay? So I will make that as optional quantity, optional attribute. And now we have this one, this just like they represented relationships, representing those links, okay? It's not a regular entity, it's not regular objects, all right? Now, what I'm going to do is I'm going to replace this with 2 separate links connecting orders with the link with lines and products with these lines. So I'm going to create, so this will be one-to-many relationship. I can just simplify that with one-to-many here. So here, order contains those order lines, right? So has those order lines. One order may have many of these order lines, okay? And then it is required to have at least one order line, so that's not optional. You see that? This is not optional, it's required. On the other hand, each order line will be for one order, and each order line it cannot be optional. So each order line must have order. So this is also required. And that's not all. This time we have to make sure that this box is checked, so-called identifying one. So what does that mean? It means that this order line does not have ID. Do you see that? Cannot be uniquely identified by itself. It has to be identified by which order and which product this order line is for to be uniquely identified. So in other words, I need this relationship to identify me. Okay, so that's why on the relationship, it said check, make sure you check identifying this box. Does everybody say that?
Would that be considered a weak object then?
Kind of like a weak object, yes. Kind of like a weak object, yeah. But this time we have to use this identifying attribute for both. So just a second, okay, you will see that. Yeah, very good. That's a good point. So now we have this kind of like make this a weak entity, right? And then we also do the same thing for the product to this one. So then we just create a one-to-many relationship between product and this order line, okay? And the product is in, okay? It's in this order line. And the one product can be product in many of these order lines. Does it make sense? So one product may be in many of these order lines because many different orders, right? We have to think of that many different orders here, okay? Each order has many order lines, right? So the product can be in many of these order lines. And then each order line will be, no, each product can be in many order lines, but each order line is for only one product, okay? Each order line is for one product. Does it make sense? So just think about the link, okay, between product and between product and the order. There's only one link, right? That link will correspond to one order and one product, okay? And on the other hand, optionality. So product may or may not be any order lines because it may have not been ordered. So this is optional. But if you have order line, it will definitely have a product. So if you have order line, the order line will definitely have a product. So this is required. Okay. And again, we need to check this identifying box. And then apply. Okay. So now you see that this is not just kind of like Wikinity, but however you have, this this object requires multiple relationships to be identified. Wig entities will only require one relationship to be identified. And we'll have this. I think I already did that on whiteboard, but I will do that again with library case. So after we have that, then we can get rid of this relationship. So just press delete key, and now it will ask you, do you want to delete view or remove view or remove object? Do you see the difference? Remove view, just simply delete this from this model, from this diagram only. So some other models, some other diagrams may still have this. Okay, but if you delete the object, then basically this relationship will be gone, will be deleted out of your repository. You cannot be appear in any other places anymore. Simply delete the key. Select the relationship and delete the key. Got it? Okay, and then delete object. Let's remove object. All right, so that's it. So now this is it's kind of limited scale of our auto system. Okay, 51. We really don't have a lot of time. Let's take it. Let's take a 10 minutes break. Okay. Oh, is this time? Our class ends at 8:30, right? So we have only 40 minutes left. 9:15. Okay.
9:15.
Okay. So I'm surprised why we have such a short time. Okay. So we have enough time to do that. So let's take a break. Let's take a break until 8 o'clock. Okay.
Okay.
So I'm going to pause. Okay. So now let's do one more ER diagram using data modeler. So let's see and get rid of that. Okay, data modeler. All right, so now let's create another one. Let's call that, let's go to subview and say create a new. And we'll do library case, library example. So in library checkout system, we need the data on those borrowers or students, right? So we need a student. So let's just put those attributes, put the objects first. And then we need a book. Okay. And then we know also that we need to have a book copy, right? So book, this is the book title, and then the book copy. Okay. And that relationship should be one to many. Let's put a relationship first, okay? So one book may have many book copies. So let's say book has book copies, all right? And then book has many book copies, and the book copy is for one book title. Okay, the book is book title. Okay, and then book may or may not have a copy, so that's optional. But a copy definitely will be for a book. If you have book copy, then you'll definitely have a book title, right? Okay. And then this time we also check identifying. So that means the book copy will require the book to be identified. Okay, that's okay. So this is a weak entity. Okay, and then student check out books, make reservations. So we'll make two more objects. Check out. And the reservation. Okay. So before we put attributes, let's think about how we connect these related objects, right? So student check out books. Which one? Book copy or book? Student check out which one? Check out book or check out book copy? Book copy. So we need to connect check out with book copy. So let's put it here. Okay. So we will do students with checkout. So students does checkout. Okay. Student can do many checkouts. And the student may or may not do checkout, so that's optional. But each checkout will be for one student, and each checkout will definitely will be for students. So this is not optional. Okay. And then checkout with book copy. So that should be many-to-many relationship. Okay. So checkout contains book copies. Each checkout have multiple book copies. Okay. And each book copy may be in multiple checkouts. Does it make sense? Because library books is recycled, right? So after you return your book, with the same copy may be borrowed by, maybe checked out by different student, or maybe the same student at different checkouts. Okay, so each book copy may be checked out multiple times. Okay, so that's mandatory. All right, now let's say each checkout will definitely have a book. So this is not optional. Make sense? But a book may or may not have been checked out. So you may have library books never been checked out. Make sense? So this is the cardinality. Okay, now let's do reservation. So student resolve books. So that's one-to-many between student and the reservation. So that makes student make reservations. Student can make many reservations. Okay, and each reservation is for one student, right? And the student may or may not have reservations, so that's optional. But the reservation will definitely be for student. Okay, option, that's required. And now reservation will resolve what? Resolve book copy or resolve book? You don't resolve book copies, you resolve book titles, right? So I want to have this title, then the library will just send you the whatever copy is available to you. So I'm going to put just connect to the book title. So that should be one-to-many, I think. Let's see. This also contains. Okay. So reservation contains resolve, just a resolves. Okay. Resolves. Okay. each reservation resolve how many books? You can resolve multiple books, right? In general, right? Okay. And then each book can be resolved by multiple reservations, right? Okay. And then reservation will definitely have a book, so this is not optional. This is required. But the book may or may not be resolved, right? Optional. Apply. There we go. Okay. Now let's just put a couple of attributes. Put a couple of attributes. Just signify some, basically what do you mean by checkout? What do you mean by reservation? Let's do reservation first. Okay. Let's do reservation. So reservation will have reservation ID. Let's just use a char for that, and let's say that would be like 12 characters, and then that's a UID, identifying attribute. And then reservation will have a reservation date. Okay. And then let's just say that is logical, that's data time. Right? And let's say we'll have that as a required. Okay. And then what else could I put on the reservation? Reservation ID, reservation date, priority, reservation priority, urgency. You can? Okay, so let's just say now I have a second thought. What if a reservation have multiple books? A different book has different urgency. Then urgency should not be attributed here, right? Okay, and now let's just add one more thing, just say note, okay? Note, so you can just add some kind of a extended note. So I will use voca for that, voca, and we use like 500 words, 500 letters, and that's optional. So that's reservation. Okay, now let's do checkout. Checkout, of course, have transaction ID. We use char and then maybe 12 letters, and that's primary UID. Okay, and then checkout also have checkout date. That's data time. Okay, and then that is required. Okay, now what about the due date? What about due date? Should we attribute here? Well, return date, you return by which date, which date. You have to, you say you borrow a book or borrow a CD. So now this is also a situation that you may need to have different return due date for different items. For example, a book may be returned in 1 month, or CD must be returned in 1 week, something like that. So again, the due date should be also not here. Okay, so I'm going to just leave it here. All right, so student, that's the easy one, right? Students, easy one. Book, do we already have a book? That's just first time the first time we did that. So for book, let's just put some attributes. So you know that book has ISBN number, right? And that is, let's say 14 characters. And then this is the primary UID. And the book, of course, has title. And the title shouldn't be enough if you have 100 letters. Okay, and that is required. And the book should have abstract. And abstract should be voca too. Let's just make it 2,000 characters. Okay, and let's just say this is optional. Okay, so I will stop here. ISBN, a number of pages, maybe. Pages. So I will use numeric, total number of pages. That is maybe four numbers. So up to a couple thousand pages at the most. And this is 0, so no decimal place. Okay, and then an optional maybe. Okay, so that is a book. Now what about a book copy? So book copy has a copy number. Okay, so that is simply just numeric number, like 1, 2, 3. So I'm going to use 3. So assuming that you can have each title can have up to 999 copies. Okay, and this is 0. And that is a primary UID. However, it's not unique ID because the copy 1, copy 2 cannot uniquely identify a copy. Okay, it has to depends on the ISBN number to be uniquely identified too. Hold on, is this what did I do? Okay, is this automatic in there? So we did not do that, right? Okay, so that's because we checked that bar.
In there.
Yeah, so the ISBN number is already copied to you. Okay, that's good. All right, so we'll do that and then just say apply. And next, so copy condition. And there should be a chart, maybe like 50 characters to describe what is the condition of that. And that's optional. Okay. And then let's do one more. Let's say purchase price for the copy. And that is numeric. Okay, so numeric purchase price, let's just say maybe a couple $100. So we'll do 5, 2. So you can have up to $999.99. Okay, so that's optional too. Okay, there we go. So we have the attribute. So I will forget student one. Okay, student is easy one. Student secretary, student number, student ID, student first name, last name, email address, all that. Okay. So now let's just handle how we're going to handle the situation that in different reservations, different books may have different urgency, priority. Apparently, that urgency or priority depends on reservation and depends on the book. So it depends on both. So therefore, we should have a gerund to cut in the middle between this, cut in the middle of here. Does that make sense? Okay. Similarly, between checkout and the book copy may have different due date. Different due date depends on the checkout and depends on the book copy. So we should have a gerund to cut in the middle here. Cutting here. Okay, so let's create those two gerunds. The first one is, say, let's say urgency or priority. Okay, so we just have one attribute. Okay, so you can just have like a priority or high priority, low priority, something, or maybe urgency. Okay, so we'll just use simple char. Maybe few letters, 10 letters, okay? And then, okay, that's it. That's, we can even make that optional. Okay, so you don't have to indicate urgency. So urgency could be very urgent, extremely urgent, very urgent, urgent, or not urgent, okay? So you can have a couple of values for that. All right, so now let's just say we're going to connect this a reservation to that, and this is more like a reservation line, and the book to that also. Okay. So one to many. Okay. So each reservation has different reservation lines or priorities for each item. So each reservation may have multiple of those books, and each one, basically each link, okay, each priority is for one reservation. So that's one here. In terms of optionality, reservation, we definitely have at least one, right? At least one of these links. So this is, otherwise there's no reservation. So this is required. And similarly, each priority, each urgency line, or maybe let's just change this. Maybe we need to change this priority to something like a reservation line instead of priority name. So let's cancel this. Okay, so I'm going to change this name. So change this to reservation line. Okay, so that will be easier to name this relationship. Oh, what? I changed the wrong thing. So this is actually urgency, which is correct. Urgency. Okay. It's just the general one. This is reservation line. Reservation line. So each reservation line is for one book. Okay. What? Did I do something wrong? I changed it to reservation line. Reservation line does not allow me to do that. Okay, I typed something wrong, I guess. Okay, so now let's do the relationship again. So one-to-many from reservation to reservation line. Okay, so has this reservation line, many of these lines, and each reservation line is for one reservation. Okay, and the reservation will definitely have reservation line, but on the reservation line definitely will have reservation. So they both are required. And then we need to check identifier. Apply. Okay, so we have a little bar here. Then let's do the other way. Each book will have multiple reservation lines, and each line will have one for one book. Okay, and then each what is this? The book may or may not have reservation line. Basically, a book may or may not have reservations, right? And each reservation line will definitely for a book. Okay, so this is option. This is required. Then check identifying attributes. Apply. There we go. Now we can get rid of this one. So delete object. So that represent that relationship. Okay. Similarly, between checkout and the book copy, if I want to have a due date, we need to do something similar. So create another box, just called check out line. Okay. And attributes just simply due date. Due date. And the due date, I'm going to use date, of course. And that is maybe optional. Okay. And now let's connect the relationships to the other two. So checkout have many checkout lines, and each checkout line is for one checkout. And the checkout definitely will have a checkout line. So this is not optional. And each checkout line will definitely for checkout. So this is not optional. Okay, and then we check this identifying. There we go. Then let's do the other one. Each book copy may have multiple checkout lines. Okay, and each checkout line is for one book copy. So that's one. Okay, and then a book copy may or may not. So this is optional. May or may not have a checkout. May or may not have been checked out. So may or may not have any checkout lines. But each checkout line will definitely have a book copy. And then we check this identifying attributes, apply, close. There we go. So now we can get rid of this relationship. So now we have pretty complete diagrams. Okay. Now, what if you put, say, I want to have employee information. So if you put employee information, the employee will help with checkout, right? So you can connect employee with checkout. Okay. So I'm going to skip that. We have about 40 minutes left, so I'm going to transfer to another topic. Let me see whether you have any questions. Any questions? Now let me save this whole thing. Save as. I will save to desktop. I will change this to say 641 example. Okay. Somehow I get this kind of a nuisance error, and some objects are not saved correctly. See the log details. I don't say anything wrong, but it's just always showing that error message. Okay, so we can put this aside. Put this aside, and then let's do next topic. Okay. So the next topic we are going to convert. So do so-called forward engineering, which is from business data model to logic data model translation. Okay. So basically, we use this as example. Okay, as an example because this one has the one-to-many relationship, one-to-one relationship, and also Durand. We do not have weak entities. No weak entities. This one has weak entities. So we can use this one if we want, but this one does not have one-to-one relationship. So it doesn't matter. We'll just use this one. Weak entity basically just the attribute is already copied over. So all right. So first of all, let me tell that let's look at. I'm going to do a few slides again to introduce the rules of the conversion. Assuming no questions. Does anybody have questions online? If no questions, I'm going to show the next few slides. On current slide. Okay. So we did finish these two examples. And now let's do forward engineering. So basically the rules are as follows. Okay, so each entity, each box will be converted into a table. And all the attributes will become columns in the table. That makes sense, right? Because each entity representing many objects. Each object is going to be one record in the table. Okay. So attributes. And also the ID fields, ID attributes in the boxes will become primary keys, or maybe part of primary keys. Okay, and then we also indicate required attributes and also optional attributes as required columns, optional columns. So the first part is just common sense. Okay, very simple. But now, just at this point, I just remind you that next week we are going to start with SQL, Structural Query Language. So you need download Oracle SQL Developer for next class. Okay, SQL Developer. Okay, so if you look at my getting started guide. It is the second item, second piece of software we need. Okay, just kind of pretty much same thing as what we did with data modeler. Okay, go to the same place to download. All right. Now let's say what about the relationships? For relationship is slightly more complex. So it depends on the mapping cardinality. Okay, so if mapping cardinality is a one-to-many. This is what we do. You will duplicate the ID from the one side table into the many side table. So between customer and order, customer is one side, order is many side, right? So you're going to duplicate the customer ID into orders table. That's one-to-many. Got that? Okay. On the other hand, if you have a many-to-many relationship, so for example, customer and accounts. One customer can have many accounts. One account may have many customers. In that case, you're going to duplicate the ID from both customers and accounts into junction table, into another table, in the third table. Okay? So you build a junction table. And then the primary key of the junction table is going to be the both foreign keys, combination of both foreign keys. So duplicate primary key from customer into that junction table, duplicate the primary key from account into that. So you have 2 foreign keys in there, right? So you make both foreign keys as a part of a primary key for the junction table. Make sense? Okay, so first of all, we need to understand, and then we need to memorize. And we need to make sure that this is just like a second-hand nature is built into your mind. So whenever you say one-to-many, this is what you do. Many-to-many, this is what you do. Okay? Now, what if you have one-to-one relationship? If you have one-to-one relationship, you can duplicate the primary key of any side to the other side. But just do once. Don't do both. For example, between order and payments, you can duplicate the primary key from orders table into payments table, or duplicate primary key of a payments table into the orders table. Just do one of them, or don't do both. Make sense? Okay. Very good. So what about those optionality of those duplicated primary keys or foreign keys? So what are the optionality of foreign keys? So this is the rule. For foreign keys are optional if and only if the receiving side is optional in one-to-many or one-to-one relationship. What does that mean? So if I go back to this model, okay. So let's say customer and order here. And the receiving side is order, right? So you're going to duplicate the primary key from customer into order, right? So order is going to be receiving side. So receiving side that's required, right? This is a mandatory, right? You see that solid line? So that solid line just means that the foreign key must be also required. Let's use another example here. So between order and the payments, you can do either way, right? So you can duplicate primary key from order into the payment, right? So in that case, the payment is the receiving side, and then the foreign key will be required because this is solid. You see my mouse moving? On the other hand, if I'm going to duplicate primary key of payment into order, so put PID into the order table, then the order is going to be receiving side. In that case, the payment ID is going to be optional because this is dashed. Does everybody hear what I said? Okay, so this is just remember that for one-to-many, for one-to-many or one-to-one, you need to look at what the receiving side of the relationship. If the receiving side relationship is mandatory, then foreign key is going to be mandatory. If the receiving side is dashed, then the foreign key is going to be optional. Okay? You cannot go wrong. I don't see. Say that again. What do you mean by always you will not go wrong? Foreign key is optional means those foreign key columns are optional. They can have optional. They don't have to have a value. Okay, that means you don't. So you still have to have a foreign key. Okay, it does not mean that foreign keys are optional. It just means the foreign key values are optional. You can have optional. They don't have to have values. So when you enter data to foreign key columns, those values can be optional. Okay. So foreign keys does not. Let me try to clarify the question. So it might be a little bit confusing here. Foreign keys are optional. This means the foreign key values, so foreign key attributes are optional. That means they can have missing values. Okay, so I need to make a change in that. Foreign key columns are optional or can have missing values. Okay, so that's what it means. If and only if the receiving side is optional. This is receiving side of the relationship. So make things more precise. Receiving side of the relationship is optional. Now, when you have a junction table, the foreign keys are always mandatory, always required. So again, that means just those columns, they must have data. They cannot have missing values. Okay. Okay. So that's what it means. Does everybody hear me? Now let's try into this is oh, let me save the. How do I save this? Let me save that to desktop. I think this is in my download photo. So let me see whether I have any more photos and many more slides, and then we'll move on. Okay, so here, this is the example we just did with a little bit more extension. So I'm going to use this example to do conversion, okay? All right, so let me close my PowerPoint. And then I'm going to just put this aside and I'll use this one as a reference. And then I'm going to use a whiteboard to draw the tables. Oh, whiteboard. So I'm going to clear existing ones. Okay. So this time, I want to take a note. Or if you want to just listen, make sure you are going to take a notes, write that into your notebook. And we are going to use that for next class. Okay. So let's use this example to follow, to implement those. Let me see, this is Ravi. I don't know, how can I get rid of this? Okay. All right, so first thing we want to do is I'm going to have at least 1, 2, 3, 4, 5 tables to begin with, right? Let's create those 5 tables first. So the first table, hold on. Okay, first table is still customers table. Customers. So this is a convention. So when I name the entities, name objects, I use singular noun. And then when we make tables, I use plural noun. And then table has following columns as customer ID and has last name, first name, and then straight. City, state, zip code, state, zip, and the email. I need a little bit more space. Let me just move this aside. And the password. Okay. And then let's say we also need to mark this so-called identifying ones and also required ones. So this is how I mark. So for primary keys, I'm going to just underline that. I just say that is going to be part of a primary key. And then for all required and optional, I'm just put a little sign here. Okay. And last one is optional. Okay. Now let's do a second table. autos. It has auto ID, auto date, promise date, and auto amount. And then auto ID is a primary key, part of primary key. At this point, we just simply underline it, but we need to decide the primary key, foreign key later after we have relationships. Okay, this is required, this is optional, and this is required. Okay, the second table. And third table is the payments. We have payment ID, payment date, and the payment amount. Okay, and this is required, and this is primary key. So we need to underline that. Okay. Now let's do, let's do order line and the product. So product first. Products. It has SKU, description, color, and the price. Okay, and SKU is a primary part of primary key. Description is required. Color is optional. Price is optional. Price is optional. Okay. And finally, we have one table just for order lines. Order lines. At this point, it has only one column, but we will have more columns later. So quantity, and which is optional. It does not have an ID anything yet. Okay. So all 5 tables are result of the first rule. First rule number 1 is about each box becomes a table with attributes become columns. Okay. Now let's handle relationships. So when you have very complicated ER diagrams, you probably want to use a pencil to cross. To say when that one is done, just cross it, so you can remember. Don't have to duplicate, right? So first, between customer and order, that's a one-to-many relationship. For the rule to apply, one side into many side. Okay. So duplicate primary key from one side into many side. So you're going to duplicate the primary key from customers into orders. So customers have ID. Okay. So primary key for customers is already declared, is already determined. So it's a customer ID. So we have to do, we just simply do that, put into here. So customer ID here. All right, and now I will make this as sort code, foreign key as a sort code. Okay. So basically, this is primary key, this is foreign key. If you want to draw a line, for simple models, you can draw a line, but for complicated ones, it's going to be a little bit more complicated, more sophisticated. So let's just say primary key, foreign key, right? So the foreign key. Is this foreign key required or optional? So receiving side is auto side, and look at this relationship. This is required. This solid line, this line receiving side is solid. So therefore, this foreign key is going to be required. So we will mark that here. So this is required. Okay. So now we can see this part is done. Okay, you can check, cross this out. Now let's do this one. Between customer and order or payment, between customer and payment. So we're going to duplicate primary key from customers into payments because that's one-to-many. Pretty much the same thing as for orders. So I'm going to duplicate the primary key from this customer ID into here into payments. So let's say customer ID. Okay. And then that's, just have another relationship connecting to here. And is this foreign key required? Yes, is required. According to the relationship. This side is solid. The receiving side, the payment side is solid in the relationship. Yeah. So therefore, payment is required. Okay. Now, it is required. We're going to write a code to implement. But at this point, we can just tell you that this customer ID is primary key for customers. But when you duplicate that as a foreign key, the foreign key does not have to use exactly same name as primary key name. So for example, here, you can call that a customer ID. You can also change that to, say, customer, or maybe some other names that make more sense. Okay, so if you make customer, that probably will make more sense because in order you have order ID, order date, and then there's a customer. So the customer is actually customer ID. Okay, the content is the same, but just name. Name makes more sense because if you put customer ID, CID here, sometimes it may not be clear what does CID represent, right? CID what? Customer ID or maybe client ID or whatever. So it might be a little bit of confusion. Okay, so we will just, you can change the name, okay? But the content cannot be changed. Same thing here, this could be also changed to customer, okay? Or maybe payee, okay? The person who make a payment, payee. All right, so we handle two relationship. Now let's handle this one-to-one. So for one-to-one, I said you can either do order ID into the payments or payment ID into orders. So either one. So which one does not matter which one. So I will just do the payment into orders. Okay, payment ID into order table. So that means you are going to create extra column here. And that's called PID or maybe called payment. Let's just use payment. Okay, payment. So which is exactly this one. Duplicated. Is exactly payment ID duplicated. Okay, is that foreign key required or optional? Look at the receiving side. The receiving side in this case is order. Order side is optional. So this is order is a receiving side. So therefore, the foreign key is going to be optional. Okay, so that doesn't mean that make sense because when you have order, the order may or may not have a payments. You know, maybe the payment value, payment attribute may be optional. Okay, maybe missing. All right. And we have there's two more relationships here. Okay, so they both are one-to-many. So let's do this one first. Orders, order line. So duplicate primary key into the order line for an orders. So you're going to duplicate order ID in here. So one foreign key. So that is down from here, from orders. Okay. So that's one handled. But then, because this little bar means that foreign key you duplicated is going to be also part of primary key for this order line. Okay, so now we need to handle that. So we need to underline this also, not just circle, but also underline it. Okay. This OID is going to be part of a primary key because of the little bar, indicating that the order line is going to use this order ID as part of a primary key. And then look at the other end. This one, same thing. Product SKU is going to be duplicated into here also because it's one-to-many. So we'll do that. Okay, so duplicate product ID into order lines. So that's SKU, and that is a foreign key, and that is duplicated from products. So here. Okay. And that is also part of a primary key, so we underline that. Okay. Because there is a little bar. All right. And that's it. We're done. And now I just need to make sure that this is connected to orders. So this is order connected to the junction table. Connected to here. Okay. So the diagram I just created, this diagram with primary key, foreign key links. And this is called a Bachmann diagram. Oh, what did I do? I did a cut. What is that coming from? Oh, this is coming from here. Cut from here. Okay. So this is the whole thing is called a Bachmann diagram. So it's more like a relational model. So on the relational model, you basically have columns, primary key, foreign keys, tables, relations, and also rows. Okay. On the ER diagram, you don't have those tables. You don't have primary keys, foreign keys. You can only have relationships. You have a primary UIDs. Okay. I have attributes. So you're using different set of terminology, different set of terms to talk about things. To talk about different items, elements inside the model. Okay. So this will become a blueprint for your database to be designed, to be implemented, to be constructed. So you need to use SQL to do that. We do not have, this example does not have many-to-many relationship, have a few more minutes. So let's try to have one to handle many-to-many relationships. Any questions at this point, anybody? So let me see whether I have a way to save this as like a picture. Send an email summary. Okay, I'm gonna do that. Summary. Hopefully, it says send. Okay, good. All right. What is this? Where's the? Okay. Sometimes arbitrarily cut things out. All right. So now let's see whether we have any like a one-to-many relationships. So if I have a many-to-many relationship, so this one, because this was many-to-many, but we cut that, we make a Durand cut in the middle, so the many disappeared. And so what if we have just simply many-to-many relationship somewhere? Let me just open up the PowerPoint. I think we have an example for that. Okay, very last one, I think. Oh, let's do a different one. The bank one. Okay, let's do this one. Okay, still have time to do that. So this one has a many-to-many, many-to-many, one-to-many here. Okay, so I am going to make this slightly bigger. Can you see it? Okay. So let's create another relational model for customers. So we'll have 4 tables to begin with. So for this one, I can just close. All right, so let's do second one. Okay, so first of all, create 4 tables. Customer table. Okay, so customer table is going to have customer ID, customer last name, and a customer state. Following that, following this ERD in the PowerPoint. So this is going to be required. This is going to be primary key, and this is going to be required. And this is, oh, this is optional. Sorry, this is optional, and this is required. So 1 table. Now let's do second table. Oh. Second table, let's do accounts. Accounts have account number, ACCT number. Okay. And then what is this? Balance. Okay. And then open date. And balance is optional. Open date is required. It's optional. This is ID. Okay. Next one, transaction. Transactions. So transactions have transaction ID, which is ID field, and transaction date, which is required, and transaction type, which is required also. And finally, we have employees. Employees. The employees have employee ID, employee job, and then last name. EID, job, optional, and then employee last name. Let's just try to make sure, yeah, employee last name is required. EL name is required. Okay, so that's just basically based on the first part. Each box becomes table. Then we need to handle relationships. So here, between customer and account, you have a many-to-many relationship. So we are going to create a junction table. Let's just put a junction table here. Okay. Junction table here. So we are going to duplicate primary key from customers into that. So that's customer ID. Make that as foreign key. And then duplicate primary key from accounts into that also. So that is account number. That is also foreign key. Okay. So if you want to draw lines, that basically just like that. Okay. Okay. And then for junction table, the foreign keys are always required. Get that? Okay, so now let me ask you, how many foreign keys does this table have? A foreign key is duplicate the primary key. So each one is a foreign key. So there are 2 foreign keys here, right? So a table may have a 0 foreign key, like this one does not have foreign key. Sometimes may have 1 foreign key, sometimes may have 2 foreign keys, maybe more than 2 foreign keys. Okay, so this one has 2 foreign keys. Now, what is the primary key for this table? What is the primary key for this table? So for that, you have 2 choices. You can make some kind of like an artificial primary key. Maybe this is called like ownership ID or something. But in general, you can just make these 2 foreign key in combination as a 1 primary key. So combine both foreign keys together as a 1 primary key. So that would be a composite primary key. Okay. A primary key consists of multiple columns. All right. Okay. Now let's go back to the PowerPoint. So now we have one-to-many between account and transaction. That's a one-to-many. So we duplicate the primary key from an account into transactions. And that foreign key is required. Do you see that? This is a solid line. The receiving side is solid. The many side is solid. So I'm going to duplicate the primary key from accounts into transactions. So we'll do it here. Okay. So that will be account. So you can just say account. It's actually account number, right? So it's duplicated here. This is account number, okay? And that is required. So that foreign key column cannot have missing values. So that means what that means is each transaction must have account number as part of the record. Okay. All right. And now we have many-to-many relationship between transactions and employees. So we create a junction table between employee and a transaction. So we can do it here. So for that, I duplicate the primary key into from transaction to it. So that would be transaction ID. Or you can change it to transactions if you want. And then employee ID will duplicate here also. And the both will be also required because it's the junction table, okay? So look at here, originally the relationship was like optional to optional, but it's not a matter. As long as you have a many-to-many relationship, the junction table is going to have required foreign keys. So they both are required. And again, we can also make this table like a 1 primary key, composite primary key consists of those. Now, how do we name this the junction table? We can name that in the more like descriptive names. So let's say we have a descriptive name here for this one. So this basically just indicates which customers owns which accounts. So we can say this is ownerships, right? Ownerships. So that is more descriptive. But then when you come to this table, this tells which employees helped which transactions. So it may not be easy to find a name. So but then we can just use, say, some kind of brief name. So employee transacts. So use the first few letters of each end objects, and then just make up a name for the junction table. Okay. So that way we can tell that this is some kind of junction table between employee and the transactions. Does it make sense? Okay. We have 10 minutes left. I have one situation I do want to cover, which is about. Now let's see. We have that actually. So let me close this PowerPoint. So that situation is interesting. It's important actually. I'm going to open up this PowerPoint, this data model again. is about the weak entities. And then we have weak entities. And let's say open desktop 641 example. So actually that was library case. So in the library case, we have a situation like this. Okay, we have a checkout, and then the checkout items. Oh, this one, let's do this one. Okay, this one is more, which one? This one. So this book copy is the book copy one. Okay, so this checkout, and there's book copy, and then the book. And when you have weak entities, make sure you finish the weak entity, finish that implementation of the weak entity first before you connect the weak entity to others. Okay, so what does it mean here is when I create a table for this ERD, I will create a book and a book copy and make sure that that weak entity is handled first before I can handle this relationship. Okay, so let's say why. Okay, so now let's say go to the whiteboard again. So I will create one for book, right? So that's easy. So books. So books have ISBN, that's UID, title, that's required, and then abstract, and that is optional, and then pages, that's optional, all right? So have that, and then let's do book copies. Book copies. So for book copies, we have copy number, this is part of UID, and then we have condition, which is optional, and then purchase price, that is also optional. Okay, and now let's handle this weak entity. This is relationship with the book. So basically you have one-to-many relationship with the book. So you're going to duplicate the primary key into here, into the book copies. So you put ISBN as a foreign key. Okay, and is that foreign key required? Solid, right? Okay. Is required. And also this foreign key is going to be part of primary key because of this little bar. Just like what we did with associative objects. So this is going to be primary key also here. So essentially, what is the primary key for book copies? Combination of ISBN number and a course number. Make sense? Okay, so now let's do two more tables. One is checkout. Check out. So for checkout, you have transaction ID, which is ID, and then checkout date, okay, which is required. And then let's handle this relationship, this one, this gerund, okay? So going to create another table for that, for checkouts, for checkout lines. Check out lines. So that table at this point has only one column, which is due date. Due date is actually optional here. Okay. And then we need duplicate primary key from checkout into that. So checkout, which is transaction ID, we can do transaction ID, duplicate as a foreign key, and that is basically connecting that to here. Is that required? Of course. Okay. And this also, because of this little bar, this foreign key is going to be also part of the primary key for that. Now we need to duplicate the primary key for book copies into here too. So what is the primary key for book copy? What is the primary key for book copy? Copy number? you need to also include ISBN number because the book copies primary key consists of 2 columns. So you need to duplicate both columns into that table. So that's why I want just have a last part to indicate that. So ISBN all together, primary key duplicated, okay? So if primary key of table consists of 2 or more columns, you have to duplicate all of them into the other end if it's a one-to-many, okay? So now, what is the primary key for this table? This transaction ID is a primary, this foreign key, this is a foreign key, and this is another foreign key. So how many foreign keys does this table have? 2 foreign keys, not 3. If you say 3, that would be incorrect, okay? Because these 2 columns, just 1 primary key duplicated. So therefore, it's a 1 foreign key. And of course, they will be also required, and they will be also part of a primary key. So now the checkout lines is going to have 3 columns as a primary key. Composite primary key consists of 3 columns. Got it? Okay. So this is this special situation we need to handle. Of course, when you do checkout, you have to make sure that student ID is going to duplicate into checkout. So that will be foreign key only. Foreign key from student ID to checkout, okay? And then you can translate other 2 objects, all right? So I'm going to stop here. Let me send this to me as an email also. And then we're going to write a code based on this example. Okay. All right, so I'm going to pause for a second to see whether there's any questions. Does anybody have a question online? Let me stop recording for a second.